Hi everyone, I am SS Kiran. I would like to discuss about execution of Simulink blocks of following base paper. Okay, that is series compensator based on cascaded transformers. Okay, coupled with three-phase bridge TPB converters. Okay, coupled with three-phase bridge converters. Okay, as converters, right? Series compensator based cascaded transformers coupled with three-phase bridge converters. Okay, see the following block diagram. Okay, this can be called as a proposed multi-level series compensator. Okay, that is called MSC. Observe here. Here I am highlighting proposed multi-level series compensator. Okay, in that I have discussed about series APF without DC source, DVR with DC source. See the title once again. What is that? That is called series compensator. Series compensator. In that I have to discuss about this paper proposes a multi-level series compensator, that is called MSC. What is that? Multi-level series compensator. Here I am reading abstract, right? In this abstract I have to observe voltage sags and swells. Then second one, harmonic compensation, reactive power compensation. These three parameters are very important, right? In that can be considered as a DVR, that is called dynamic voltage restorer. Okay, at the same time series APF, that is called series active power filter. Actually the MSC, what is that? MSC, multi-level series compensator, can improve the power quality. What is that? Power quality of loads located stiff systems. Okay, by using three-phase bridge TPB. Okay, actually in that we have to use K times of TPBs are used. Observe the following block diagram. Okay, that is called n times, like, or K times, converter 1, converter 2, up to so on converter K. Okay, some voltage sources, three phase, like 1, 2, 3, right? Now see the title. Okay, in that title, the multi-level or series compensated three-phase converter, we have to use PWM technique also. Okay, okay, actually the main three parameters are voltage sag swells, harmonic compensation, or reactive power compensation with DVR, that is called dynamic voltage restorer, with three-phase bridge, right? A number of times. Okay, K TPB converters are connected here, right? Okay, some techniques also we can discuss in this topic, that is called series APF, active power filter. Okay, see one by one what are the main blocks in that one. The first one is the transformers. Okay, three-phase transformers coupled here. See, first transformer is connected to second transformer seriously compensated with third transformer. See this is the converters. Okay, converter 1, converter 2, converter up to K on. Okay, based on that is called some ideal equivalent circuit also we can observe here. Right, just generally observe the base paper from quick reference, right? In that we have to concentrate following results. This is some real-time example. Three transformers are coupled with each other, connecting some IGBTs or some power electronic diodes. Okay, this is the output waveforms, like grid multi compensated, right? This is the output waveforms. One is the grid, second one is DVR, and the third one is the load outputs. These are all outputs we can observe in the following Simulink blocks, right? Okay, coming to the some compare with title and block diagram one by one. This is converter, converter 1, converter 2 up to converter K. Okay, these three transformers is directly coupled with these converters. Now open with MATLAB 2010A, double click on that MATLAB 2010A. Now come back to the PDF file. See here, what is that? There is three bridge. Actually, this is the DC source. Up to three converters. I could think is a three-phase bridge. Okay, based on the title, we have to solve this one, right? Now I will explain how to open this file. See this in the desktop. I have placed this total file that is called series compensated file. Just click the open button. Okay, and click the desktop. Observe series compensated based on cascaded. Then click a sag CFE sag cell. Okay, in that you have to click main. Okay, then okay, main button. Then click open. Okay, then some small code will be open. Click open button, right? After that, so observe here, I have written some code. See here, actually in the base paper mentioned so many graphs. Okay, in base paper mentioned so many graphs. Observe once base paper. So before going to the base paper, what are the titles? Proposed multi-level series compensator, we can also called MSC, right? The second one is DVR with SAG. DVR stands for dynamic voltage restorer, SAG. The third one, dynamic voltage restorer with swell. Okay, then DVR, SAG and swell. These are all blocks observed in the our base paper. See one by one. Okay, that is first one is the proposed multi-level series compensator. Sometimes I have called MSC. See the first one, proposed multi-level series compensator. um, I have designed Simulink block also. One by one I will show one by one, right? Then second one, voltage sags and swells. The first property, voltage sags and swells. The third one, reactive power compensation. Three, we can observe three parameters in this base paper at the same time in this Simulink block. Then in that base paper, then what is that is called, see how I can execute. I will explain. Click here run button, that is the run button. See here, just click on then run main simulation. Here very important point, you have to click this change folder. Okay, don't click on add on path. Okay, add to path, click this change folder, right? This is some GUI, graphical user interface menu. See here one by one. I have designed what are the parameters here, what are the blocks. What the first one is proposed multi-level series compensated. Okay, the first one that is called. So minimize this one, right? Okay, not minimize. Okay, then the dynamic voltage restorer DVR, dynamic voltage restorer have highlighted there. Okay, then actually this is two parts, one is sag and third one is swell. And simultaneously I have done both DVR sag and swell also. See here the first point deals with voltage sags and swells. I have designed that block also. Then one more point is multi-level inverter with PWM technique. This is also I have discussed. Okay, not here. And that some discussion part I have observed the PWM technique. Okay, at the same time, just you read the abstract, you will get some conclusion. Okay, that is called see observe. Better you can maximize, you'll get some knowledge about this PWM technique also. In the introduction part, I have observed multi-level inverter with PWM technique. Okay, see, there is a PWM strategy. Okay, multi-level waveforms strategy. That block also I have designed here. Then the next one, series power active filter, that is called series power active filter. Okay, the next one is UPQC. Okay, that is also I have designed here. based on reading of introduction part, the unified power quality conditioner, at the same time power series active power filter also. Okay, now we will execute one by one, then you will get some awareness of this base paper results, right? First double click on the, not double click, the single click on proposed multi-level series compensator, then it will be opened slowly. Just observe here, some indication is there. Yes, this is the basic our proposed Simulink block. Okay, right, series compensated based on cascaded transformed coupled with three-phase bridge. So then open our main block. Okay, that is in that block you have observed some three inductors. You can also observe here three inductors, 1 2 3 here, that is three transformers actually, some phases A B C. Okay, three phase, 1 2 3, that just now I have shown that inductors, right? Whatever you can observe here, same Simulink block, right? Just check here Simulink block, then you can understand. Then there is a three phase, phase 1, phase 2, phase 3, right? Better close some extra blocks, then you will remove some confuse, right? Okay, then close some blocks, right? Then you will get some clarity, right? Okay, better to close output files also, right? Okay, then good. Then coming to compare with our basic Simulink block or proposed Simulink block, right? There is a three transformers, right? See here, there is a three transformers, right? 1, 2, 3. Okay, then again this three phase bridge, that's why I have connected three transformers coupled here. Okay, that is our title said that three transformers are coupled, right? That's why I have coupled three transformers coupled. Okay, if it's a three phase bridge, then three transformers will be coupled, right? Then coming to Blake, then after that so the third series, so I will show the step by step, right? Right. Then after that I have to connect converter, right? That is converter in the form of the three phase bridge. Double click on series, in that see observe, right? Series filter, right? The second one, and then 1 2 3 4 5 6. Okay, 1 2 3 4 5 6, right? Okay, this is converter to, I have designed converter 1, and then this is the second one, converter 2. Okay, right. Okay, using IGBTs, right? This is the some converter 3. Okay, see here, converter 3, double click on series filter. Okay, this is the converter 3. Okay, these three are connected seriously, that's why it is called series compensator. If you connect parallel, that will be called a parallel compensator. Okay, that base paper also available in the in IEEE digital. Okay, see resistors also have connected. This is the voltage sources, right? DC, okay, DC2, DC3. These voltage sources also you can observe in the proposed MSC, right? Right, MSC, DC1, DC2, right? In that there is a DC source. Okay, this is grid, that called the, initially I have connected grid. Okay, then come back to the, then it is called load, just you have to observe load also, right? Come back to the series compensator. See, this is active filter, this is some functions, some doing some mathematical calculations in the base paper. In the base paper you have observed so many mathematical calculations. Just writing the mathematical calculations, you will get some mathematical expressions. Based on that, you have to observe. These are all calculation part, right? See one by one, in the complete base paper there is a lot of mathematical equation. Based on this mathematical equation, you have designed like in this way, right? Yes, come back to the original proposed system, that is proposed multi-level series converter, right? See, there is a three-phase bridge and three converters, right? This is the complete proposed MSC. Okay, this is the load. In this load we have also some diodes, right? Now there is some main data acquisition system is also very important thing of collection the data from the grid, and collection from the grid to transformers to converters to this one. Right now trying to execute the program, click on that delta symbol or arrow symbol, right? See here, now observe, there is some time mentioned here, t is equal to 0 point executing. Now program will be executing. Just simultaneously you have observed the results, what type of results you can expect in the coming block. See here, there is a various results are behind in this base paper. Based on the results we can conclude that, right? See them swell, grid, MSC, DVR. Okay, see, they click on scope button, right? Simply click, single click, that's enough. This is the output. This the first one is the grid voltage, and load voltage, and applied voltage or initial voltage. So whatever we can expect the grid DVR. Okay, see here, grid voltage. This is our output of the series compensator. This simply combined with other waveforms. Okay, the grid voltage, load voltage, injected voltage. See here, there is a swag and swell. See here, so these are the outputs of your basic Simulink block, right? Okay, this output is completely from the proposed MSC. Okay, this is also some blocks, right? The equations that also observe the output waveforms. See the exact waveforms. These waveforms are so very just you can observe what are the outputs in that internal blocks voltage migration, right? This is the exact output of applied voltage, right? Just you have observed with the base paper, you will get these are all waveforms, right? This is one waveform. There is swell and sag, right? Close this one, then okay. These are all outputs of base paper, whatever you have observed in the base paper. Okay, this will not exactly, just doing some changing of the time period, you will get these output waveforms, right? Just close this one, at this also close this one, right? But at this one also closed. Okay, then come back to the original program. There is one more dynamic voltage restorer, DVR sag, right? This is also one block that is called DVR sag. Then click okay, DVR sag, click run button, that is the start simulation. Program is going on. Double click on outputs. Okay, that is called scope. Okay, it will get slowly. Okay, then come back to the output, observe the original base paper results. Okay, in that you have observed some, okay, right, see here. Okay, in that there is okay, DVR, this output you can observe in this graph. These are three categories, right? This is one output, right? There is a three-phase bridge. That's why there is, you can observe three colors of waveforms, right? Then come back to the block. Okay, just observe this. These are all blocks in combination with the three-phase PLL also. Okay, this PLL also you can observe at the base paper. Okay, phase local loop, right? In the base paper you have also PLL. Okay, PLL with DVR. Okay, this DVR with PLL. That's why I have also inserted this PLL block also, right? Click on output file, see this final output. This is the output, then close this output, right? Grid voltage, inject voltage, load voltage, right? Stop this one. Then we will enter into the next one, right? Okay, no, yes or no, that's not a big problem, right? Okay, now come back to the third one, right? This is dynamic swell, right? Then double click on sag and swell. This is the swell, okay, this is the sag. Then click here, the sub blocks also there in that blocks, okay. Subsystem 1, subsystem 2, in the subsystem 4 we can expect a DVR sag. In subsystem 3 you can expect a DVR swell Simulink block, right? Then just minimizing of these, just adjust with two graphs, right? Simultaneously you can observe both the graphs, okay, then you will get some clarity, right? Just minimize this one, right? Okay, just minimize this one, then click on just minimize this one. And at the same time you can also observe the next one is multi-level inverter with the PWM technique. Then you get the outputs there, right? This is the with PWM technique. This is very important, right? Multi-level multi-phase space vector PWM technique. Okay, this PWM technique also you have observed in this an abstract side. Okay, see here, PWM technique means pulse width modulation, differentially from conventional non-solenoid carrier based PWM. Okay, see here, sine wave, sine wave 1, then this is the carrier waveform, right? Okay, now execute this one in that Simulink block, okay, in the fifth level phase one. Okay, now run this button, simulation button. See here, that is the start simulation. Just then you will get output waveforms at the scope, right? Just minimize here, right? Double click here. This is the output waveform of with PWM, right? That is called with PWM. Already in previous session, this just last 2 minutes back, I have executed one file, the combined block of DVR sag and DVR swell. Just opened that one, right? So adjust both output files at a time, then you will get some clarity, right? This just minimizing of this one, see here. Then this one, this minimizing of this one, right? Right, this is the sag and swell. This is sag, the next one is swell. Swell, where is swell? Yes, this is a swell. Minimize, right? Yeah. Let's compare these two outputs, right? See here, there is a variation of these outputs, right? This is sag and swell, right? This is the output waveforms, right? Then close, come back to the original, this simply stop the simulation button, right? This is the output waveform, right, of swell. Right, close this, no, click on no, right? Okay, then come back to the original one, that is called okay, series active filter, series APF, series active power filter. The one more block is series power active filter. In that I have only designed a single block. Double click here, series power active filter. This is the diagrammatic representation. Series active filter or dynamic voltage restorer. Series active filter is also called dynamic voltage restorer, DVR. Okay, this is the output form from swag and cell. So see here, observe the output. Okay, that is the injected voltage. Whatever we have observed in the Simulink block, same we can expect in the, whatever results in the base paper. Okay, see here, same out results we get here. See, okay, see here, same grid voltage, right? Okay, these are all the same DVR outputs, right? This is straight line, same output here also, right? This is a straight line with that, which one is the highest part, right? This is the series APF, okay, active power filter, right? Okay, based on active filter or a DVR, dynamic voltage restorer also. Okay, then the last one is reactive power compensation with UPQC. Okay, in base paper you have observed UPQC, right? See that in introduction part there is a UPQC, right? Unified power quality, right? Okay, in that UPQC, by observing UPQC also we get some quality outputs, right? Unified power quality conditioner, right? uh, these three options satisfy the series voltage compensation criteria. One is PWM, then second one APF, then UPQC. These are satisfied this voltage compensation, right? Right. And then come back to the original out block and just click run button here. Okay, in that click on reactive power compensation. This is the complete block of series compensated based cascade transform with coupled transformers. Okay, in that there are so many Simulink blocks are so many blocks are designed from the library. Okay, this is three phase, right? This is some subsystem. Okay, this is also subsystem, right? And scope, there's some, you can expect some result here. These results by using UPQC in the base paper, some results are derived in that base paper. See, so many scopes are I have placed here. Just why actually why I have preferred this is some in separate block, because by using UPQC we get the satisfy this compensation technique. Okay, right? This is the sub block of this one. This is PWM generator also internally used. See here the multi-level waveforms PWM technique also used internally. So PWM technique, okay, pulse width modulation technique also used here, right? Actually this complete base paper I have solved, complete base paper with complete Simulink blocks also I have designed. See the output waveforms, this is some sine wave, this is some reversal also. See the output waveforms here, right? The one sine waveform, okay, sine waveform, and see here the waveform starts with grid with like this. You start with like this, and okay, right? MSC series APF. Okay, this is the some output waveforms start like this, then we can start with one. Okay, these are all outputs I have observed in this Simulink block. You can also observe different waveforms also. Okay, in that this is some internal block of this block one. So this is some scopes, we get some output results. Okay, right? Okay, these are all outputs of UPQC. By using UPQC we get satisfy this series compensation technique method, right? See MSC and DVR, PWM technique, and this one, this UPQC method, all Simulink blocks are separately designed one by one. Okay, this is one way to represent all blocks comes in a single window, right? Come back to the original block, right? That is MSC. Okay, right? See one by one the complete base paper. Okay, and the complete base paper, and that converter 1, converter 2, converter 3, the possible operations series APF and DVR. Same block I have designed in the that is proposed multi-level series compensated MSC. See here, same block I have designed here. I think this is more than enough for beginners. Okay, right. Thank you so much. Keep watching. I will update all the base papers results with solutions. If you have any doubts, just propose it here. Right. Thank you so much. Thank you so much. Thank you.